Guys, so let's answer question 1D. So the question, write the stepwise mechanism for the formation of compound C in the reaction below. Okay. So compound C is alkene and compound B is alcohol because of the presence of hydroxide ion here, OH groups, hydroxy group. So this is alcohol, and then the compound A, which is our starting materials or the reactants, is haloalkane or alkyl halide, halide. And then the class of alkyl halide is, look at this carbon, there is 1, 2 and then 3 neighboring carbons, so it is tertiary alkyl halide. And then we need to also consider the nucleophilus. The nucleophilus is water, which is a weak nucleophile, and then using ethanol. So we need to understand the flow or the diagram given to us. Okay, so for the compound B, which is our alcohol, the product is due to the reaction of SN1, while our another product, which is compound C, is due to the E1 reactions. Okay. So now the question asks to provide the stepwise mechanism for the formation of compound C. So it means that we need to provide the mechanism for E1 reaction. Okay, so basically there are two steps in the E1 reaction, which are, the first step is the formation of carbocation, and the second step is the loss of protons, or the loss of hydrogen atom. Why the hydrogen atom is lost? Because our base will take it as the will remove the protons and making the new pi bonds. So we will form our products, which is alkene. Okay, I forgot to share with you guys some information. Okay, so I will label here for the E1 mechanism. Our carbocation will undergo acid-base reactions, while for SN1, our carbocation will undergo nucleophilic attack by nucleophile. Okay, nucleophilic attack. So we can now start to draw our mechanism, E1 mechanism. Okay, so we draw the structure, the compound A, structure of A. So the first thing here, what happened is the bonds between the carbon and the chlorine and the halogen atom, halide atom here, will broke, and then the bonds will taken by chlorine atom, in this case as the lone pairs. So this is the products, which is leaving group, and there is a negative charge here. Okay, because of our chlorine atom just now leave as the leaving group, so the bonding here around our carbon atom in the starting material is not enough. There is only three atoms, three bondings, 1 2 3. So it is carbocation, because there is only three bondings around our central atom, carbon atoms. So our carbocation form is known as the intermediate. In this case, the carbocation form is tertiary carbocation, because the surrounding carbons, there are three surrounding carbons, one here, and one here. Okay, so let's move on. Right, before we move to the second step, you need also to know what happened in the first step. Actually, in the first step, there are two things happens, which are firstly the formation of carbocation, and then secondly the loss of leaving groups. In this case, our chlorine atom, Cl. Okay, so we proceed with the second step. Okay, in the second step, there are two things happens. The first one, the things that will occur, our beta hydrogens or beta proton will be removed by our base, which is another reactant. In this case is water. And then the second thing that will occur is the formation of new pi bonds between two carbocation, and then we will form alkene, which is a new functional group, double carbon bond. Okay, when you understand what happened in the second step, we now can proceed with our second step. Okay, so in our tertiary carbocation here, this carbon, the bonding between this carbon and this hydrogen will broken, and the bonds will get by carbon atoms, and this hydrogen now will be taken by our base, which is oxygen atom in water molecules, because in oxygen atoms there are two lone pairs, and one of its lone pair will be used to make bonds with this hydrogen atom from our carbocation. So by doing this way, our base, water, will remove these protons and take it from our carbocation. So we will form a side product or byproduct, which is H3O plus, or hydroxonium ion. This product is not important because we will only need to focus on our major products, which is alkene. So now let's see how our alkene will be formed. Okay, just now I said that the bonds here is broken, and the bonding will go to our carbons here. Once this hydrogen atom out or be taken by oxygen atom, at this carbon atom is now only 1, 2, 3 bonding, so it is also don't have enough bonding. It is sp2 hybrid sp2 now. Before the carbons being taken by oxygen atom, it is sp3, so now it is sp2 only, so it is also considered as carbocation. And then the bonding taken by our second carbocation will go to, from this side it will go here, and from here already have one existing bond, and then now from double bonds. So we now understand how this bond comes from. It comes from the removal of protons by our base. So in this way, how we can form an alkene. So that's all for this video. Thank you for watching. If you have any curiosity or any questions to ask me, can leave in the comment sections below. Thank you and have a nice day.